Can you unmute yourself and reply me if you can hear me?
Yeah, we can hear you.
Okay, okay,
Yes, clearly.
okay, okay. All right. Welcome to this webinar. Uh, we are excited to actually have you guys here. It's actually the first of its kind in terms of construction professionals for GIS as far as our organization is concerned. This is our first webinar in relation to construction professionals. We have been doing other GIS programs, but based on the fact that a lot of construction professionals are actually not into the GIS, we don't focus more on that. But we discovered that okay, we actually need to put that into consideration because we know that as an environmental practitioners, you actually need to be part of the GIS technology. Okay, so without wasting much of our time, I will share the slide now. We'll continue. Any other person can join as we continue. Okay, and then before we start, we are going to divide this webinar into two sections, possibly. The first 40 minutes will be talking about the presentation we have about the GIS for construction professionals, and then how they can use the GIS, and then the advantage of it to the construction professionals. And then the second section, another 40 minutes again, will be for the practical section where we are going to use the software. Although some of you actually says that you don't receive our mail, but we actually send the mail giving you a link to a particular video in our channel so that you watch and learn how you can install that particular software that you're going to use. So if you have installed the software, that will be very good because we'll be following it as we start here. But if you have not installed the software, that is not a big deal. You can actually watch the link later. We can still forward it to you, and then you install the software, and then you follow up the program any other time. Okay, and then also we are going to record the video, or the video is already the meeting is already being recorded. So at the end of the webinar, we'll also send you the video or the link to the video so that you can actually follow up. So any other things that you did not understand, you can do that also. Okay, so I'll be sharing the screen now. Okay, welcome guys. This is introduction to GIS for construction professionals. We all know that whether engineering or environmental scientists, any field you are, as far as you are into you are in construction industry, you definitely make use of this GIS in one way or the other because we do mainly on locations. Okay, so this is introduction to construction, introduction to GIS for construction professional. Okay, now we look into what is this GIS all about. The word GIS is mean Geographic Information System. Okay, that's the full meaning of GIS, and is a computer system capable of assembling, storing, manipulating, analyzing, and displaying geographic reference information. So any system, either your computer or any software or your phone, that as far as it can be able to analyze or as far as it can be able to interpret any geographic data is also referred as GIS, because our main concern as far as GIS is concerned, or as far as construction industry is concerned, is about the information, which is the I. Because we as a construction professional, we are into BIM, okay, which is actually the information. So we have been studying BIM, maybe building information modeling for a quite number of years now, which we focus more on the information. So GIS stands for Geographic Information System, and it combines data, technology, and GPS to create the analysis and display of spatial reference data. Now, in field of construction or engineering industry, it has come a long way. One type of technology that have helped the modern engineers is actually GIS. My name is Abu Sunday. As I said earlier, my name is Abu Sunday. I'm the team lead of CAD Structure Technology. CAD Structure Technology is actually a company that deal on CAD and GIS, okay, training and consultancy services. I'm a member of NIOB. I'm a graduate of Building Technology and also a member of Nigeria Cartographic Association, NCA. And I'm also a member of the Information Society of Nigeria. Presently, I'm a CAD and GIS consultant to Kaduna State Government. Who are we? That is the CAD Structure Technology. We are a group of GIS and CAD technicians which try as much as we could to actually bring this technology to our different professions. Okay. We serve as consultant to various engineering departments. We help people in their research. Let's assume you are into GIS or you are a construction professional and then you want to run a particular program after this training, and then you see the need for GIS and then you want to run a particular project, maybe your postgraduate or whatever courses that you want to do. We can help in providing some data for you and also help in your research. Okay, and then we also teach. Okay, CAD Structure Technology, we teach CAD, that is both CAD and GIS software. So if we go to our page, either Facebook page or our website, you'll see more details about what we do. Okay, that is a brief description about us. Okay, GIS experience. As I said, presently I'm a consultant to Kaduna State Government on GIS. That is GIS for land administration and titling. What does that mean is that we help Kaduna State Government to digitize the land administration process using the GIS technology. Because one of the advantages of GIS is that your data that you have, you can visualize the data with the real object. For example, if let's assume in building industry, you have your building drawing, and then if you want to have the bill of quantity of that particular building drawing, you only prepare that based on the present technology advancement we have in the building industry. If you are not using the BIM, you prepare those things using Excel sheet. So there is no relationship or there's no link. Like, okay, you are seeing this, you are seeing the object now, and then you are seeing the bill of quantity attached. Let's assume for a room now, you seal the bill or the quantity that is required for that particular to build that particular room or to build that particular component of the building. It will not directly attach to it because we are using a different software, and then the other software that we use for our bill of quantity is also different. So there's no link between those two things. So that makes the visualization sometimes confusing. You have to actually look at the building drawing and then you look at the Excel sheet or what you print out as your bill of quantity. But in GIS, in Geographic Information System, as you can see from the object you have here, this is the digitized land. Okay, this is a polygon of land, different land titles belonging to different owners. Okay, so what we do now is that we digitize the land. All the properties or all the buildings that has a title or that is registered with the government in Kaduna State is being digitized, and then the name of the owner is assigned to that particular property. So if you want to, even in the next 100 years, as far as that land is there, and then you have the C of O for it, it's already allocated to you, and your name is already in the system. Okay, so that is one of the importance of using GIS for land administration. Then we also use GIS for building development control. That is the agencies that control development in Kaduna State is called KASUDA. So we help them in digitalizing the building development control. And how do you do that? For example, if you do our drawing in let's assume an architect doing his drawing, we don't actually use coordinates presently. Okay, there's no any law that actually make it compulsory for all the designers or a building professional to actually provide their drawing materials with coordinates. But what we are trying to do in Kaduna State was to possibly enforce the process of engineers or construction professionals to be using coordinates in their design, so that as you are submitting your working drawing to the agency for approval, you submit it with the coordinates, so that the agency will now load it to the GIS environment, and then they will digitize the location, the exact location at which you are building that your structure. And then there's something we call geotagging, where we now geotag the 3D. For example, if you do your building drawing and then you produce the 3D, we can now geotag the 3D of that particular building or that particular structure that you design, so that anytime if the agency want to possibly for generating revenue, or they want to confirm if a particular building is being registered, what they need is to zoom to that locations, and then if the area on the system is digitized, that is to show that okay, that building is registered, and they can see the details of that building by just a click, and then it will display the building, the shape of the building, every information about that building. Now, this is exactly what we are doing for Kaduna State government in terms of land building development control. Okay, and then all these things we use a particular software called QGIS. In GIS, there are many other software, but we focus more on QGIS, and the reason for that will be is based on the fact that it's an open source. We want to see that. So, like the email that we sent to you, we show you how you can install that particular software. Okay, so now this is a 3D visualization on Google Earth for development control. Now, this is what we can view this thing from Google Earth. So, as a development control agency, what you need to do, as far as they submit those informations to you, what you need to do is to zoom to that particular place, and you can see the real time or see the 3D image of the place that building is being constructed. So you don't necessarily need to, because normally the traditional way of doing this now is that, okay, if they submit a working drawing, before you approve that particular drawing, you need to send your field staff to the place, to the location, to actually confirm if that particular place is empty. For example, now this location that is displayed here, as you can see, this is a filling station. So this is a filling station you can see here. Then that is to say that this particular place is actually an industrial place. Okay, so you cannot come here and then design a building in the same location for industrial for residential purpose. So now the development agency don't actually need to, send their field field team to the location of the building before they can actually see or get more information about that particular location. So this is how the 3D visualization of an area using the Google Earth. Okay, so why do we need GIS as a construction professionals? Now, one of the reasons why we need GIS is location intelligence. Okay, what I mean by location intelligence is that if you have the knowledge of GIS, it will help you in locating places. Okay. Now, for example, you are a site engineer, and then they give you a site. Let's assume you are in Abuja, and then they give you a site in Kaduna to build. And what they do is to send you the location via Google, possibly send you the coordinates. Now, if you have the GIS knowledge, what you need to do is to actually include the coordinates in your system. If you are using a phone that has a GPS, or you are using the GPS itself, you can actually include that, and it will take you to that place. You can actually do your visualization, see the location, see the features that is around that place, see everything, the access road, the road to that place, the nearest facilities. For example, you are going to the place, you want to get the nearest hotels and all those kind of things, because you don't know the place, the distance to those facilities or those infrastructures that may help you in terms of your work in an unknown place. So it will help you to actually understand what the location intelligence is all about. Okay, and then another thing again is that why we need to use GIS is that CAD software had coordinate system. Now, what I mean by that is that if you look at AutoCAD, if you use AutoCAD or if you use any of those CAD software, you discover that it is being designed with coordinate reference system in mind. So it has a coordinate reference system. What I mean by that is that the whole world is included in that workspace. For example, your AutoCAD workspace now, you discover that you can do many drawings in one page, in one workspace. Now, reason because that workspace you are seeing is the whole world. So if somebody sends you any coordinate anywhere in the world and you load it on your AutoCAD, it will fall at the exact position. But as construction professionals, or what we don't actually put that into consideration. What we do normally is, okay, if you want to design a building, you just go to a place in AutoCAD, just click and start drawing. Maybe just AutoCAD will tell you that specify first points, and then you just click and then you start without actually impute the coordinate. But if you are actually using a GIS or put GIS into consideration, what you need to do is to know the origin of the place where you want to build that house. And then when AutoCAD said you should specify first point, what you need to do is to put the coordinate of that place. And then you follow the direction or the orientation of that particular design, so that if you finish that drawing, and then somebody else, maybe a land surveyor or a town planner actually overlay it with their own layout, it will actually fall at the right position. But normally as an architect or construction professional in building industry or any other related industries, we don't actually consider the coordinate reference systems in our designs. We just click and then start drawing. So one of the reasons why we need GIS as a construction professional is that it is included that we're supposed to be using those coordinate systems. And then this GIS knowledge will help you to understand the coordinate reference system we talk about. Now, the third thing, that there's a collaboration between Esri and Autodesk. Esri is the father of GIS, as Autodesk is the father of ASC industry. What I mean by that is that, if you use if you are into software or use software, you know that like AutoCAD, Revit, and many other software is being designed by Autodesk Corporation. It's a company that designed some of those software. Okay, so in terms of construction or engineering softwares or AAC softwares, Autodesk is actually leading. There are many other organizations that actually design, but Autodesk is actually leading. And then at the same time, Esri is leading in the GIS environment. Okay, so there's a collaboration between these two people, how you can combine the building information modeling and then the geographic information system, so that we can be able to integrate those two data together. For example, you are doing your 3D model with Revit, and then you include your GIS, which is to say that, okay, you put locations and many other GIS data into it. There are many other GIS data. For example, you talk about the topography of the place, the contour of the place, the slope, you understand, the gradient of the area. Every other things can be gotten from the Esri or from the GIS environment. So there's a collaboration between Autodesk and Esri for us to be able to combine this or integrate the building information modeling and then the GIS information system. Okay, then another thing is that the world generally is going into smart. That is what we call smart city and smart infrastructures. Everything is going smart, building is becoming smart, all the infrastructures we have is becoming smart. Now, if you look at any of those buildings, any of those smart buildings that you see, or any smart infrastructure that you see, it has a GIS component attached to it, because there's no way any system can be smart when it's not location sensitive. Okay, there's no way that any system can be smart when it's not location sensitive. So because of that, for you to actually build a smart system or a smart city, you need a GIS knowledge. Okay, then we talk about the construction site plan /layout. Now, GIS will actually help us in the in our site plan. Okay. For example, now normally if you are designing a site plan, we design based on what, like, you just have the shape of your building, or the shape of the site that you want to build on, and then you just okay, position. Okay, this should be the proposed building. This should be the where you put your materials, your store, and all that. But now, if you are using GIS to actually do that, it will help us to it will help you to actually have a real-time data of it. What I mean by real-time data of it now is that if you are using AutoCAD, you are not possibly designing it on a satellite image. But if you are using GIS, you are designing it on a satellite image, and then you are designing it directly on the exact position where all those features will be. So if your building or your proposed building is 10 meter by 10 meter, you're actually bringing out that 10 meter by 10 meter in the exact location using the coordinate that you have in the exact position of it, so that in terms of movement of truck or movement of machineries within their site, there will be no obstructions, because you are using a real-time information to do your site layout. Then it will also help us in our logistics management on site when using this proximity analysis. What I mean by that is that, as I mentioned earlier, in terms of location intelligence, before you go to any site, if you are using a GIS, you can actually confirm the location of all the possible places that you are going to you'll be getting your materials from. For example, where are you going to get your quartz aggregate? Where are you going to get your fine aggregate? Where is possible where you can get your cement and any other things? And then possibly you can also look at the road to that site, the shortest route. Where will your vehicle follow, or your driver follow, to bring this material to the site? If you use GIS now, you will see the possibility of seeing the shortest route instead of following a long distance, or instead of going to one far place to get your material. If you use the GIS now, you can be able to see maybe a query or any other places that you can get your material that is actually close to your site. Okay, so this is some of the things that these are the fields that we need to use GIS as a construction professionals. Okay, now if you look at this particular image here, you see how we have our GIS even from the planning stage to data collections. For example, now I talk about location intelligence and putting coordinates into consideration in your design. And then data collections, for example, you have to get your contour, your topography of the place. If you want to design, you actually know the topography of that location, and then you can do your analysis by actually generate your contour, and then you do your designs. And then the construction process, now you can also use GIS for your setting out. Even in any other like road designs and all that, the GIS devices can actually help you to do a quick setting out, or possibly some of those advanced surveying instruments can also help you on that. Then we have data collection of the as-built survey. For example, now after you have built your building, you can also do your as-built designs at the same time, get all the necessary GIS data. And then it can also help us in our operation and maintenance, because, for example, if let's assume you build an estate, GIS will have it will help you in a very long way in managing your estate. So depend on the size of your infrastructure, GIS technology will actually help us in managing or maintaining our building or structures. Please, if you have questions, you can drop it in our chat box. We'll go through the question at the end of the slide. Okay. So what is QGIS? QGIS is a software that we are going to use, as I said. QGIS stands for Quantum Geographic Information System, which is Quantum GIS. Now, the reason why we are using it is because it's free, it's open source. For example, you know quite okay that AutoCAD is not free, although most of us we use a cracked version of AutoCAD, but you know that it's not actually free. So there are some things there's some restriction when you talk about collaboration. You cannot use a cracked version to actually do collaboration. So, but this particular software is free, it's open source, so you don't have any restriction. So you don't need to buy license, you don't need to buy anything. And then another advantage again is that it's packaged with a bunch of other open source library and tools. Now it comes with many other tools. For example, if you use let's assume if you use SketchUp, you know that SketchUp comes with different plugins. You design based on you use plugins based on your field. So if you're a mechanical engineer, you design, you get a plugin for SketchUp, maybe for piping and all that. Or if you are a civil engineer or you are an architect, you get plugins on SketchUp. So the same thing with QGIS, you get your plugins. So if you are using GIS for management, let's assume for site management, you are going to get tools, which is plugin that can help you in your field. You understand? If you are using GIS for logistics management, you get plugin that is related to logistics management. Okay, so and then it's an alternative to Esri, which is the ArcGIS. As I said earlier, Esri is the father of GIS, so it's an alternative to the Esri softwares, that is the ArcGIS, because those softwares are not they are not free. You have to pay heavily for their license. So and then using QGIS will help us to actually because it's actually users friendly. Okay. So look at that here. Why using QGIS? Because it's free. It's compatible with both Windows, Linux, and Mac compatibility. Technology sustainability. What I mean by technology sustainability is that if you are deploying any technology to any organization or you are recommending any technology to your organization, you have to look at the sustainability of that technology, whereby you can come up with maybe a certain technology, and then at long run you cannot be able to sustain it because maybe the paying for the license and all that becomes so difficult. So but if you are using this QGIS now, you don't have any problem with that because it's absolutely free, and then at the same time it's users friendly. Okay, it's users friendly. Okay, now what can you do with it? We can do everything with QGIS. If you use ArcMap before, if you use ArcGIS before, anything that you can do with ArcGIS, you can do it with QGIS. It has different functionality available. That is what I mean by that now is that different functionality, as I explained when we talk about plugin. So you use the function, you impute or download the plugin based on your own functionality, on your own field or what you want to do. Okay. The same file type as ArcGIS, import between them. What I mean by that now is that you are using the same file type. For example, like in terms of using construction softwares now, AutoCAD file is not actually the same file with SketchUp file. Just that you can actually export to a SketchUp file, you can actually export SketchUp to AutoCAD file, but they are not the same. Okay, but this particular QGIS, the file format are the same. So if you carry a file from QGIS, you can open it directly in ArcGIS without necessarily doing any conversions. So that's what we mean by that. Okay, so this is how GIS map look like. As you can see, we have the bus routes. If you have been using your phone and then you look at the traffic, maybe you want to go to a particular place and then use your phone to actually check the traffic of that place to see the movement of the traffic, or you have used your phone or any devices you have to actually locate it. Okay, then we talk about flight tracking points. For example, possibly as an engineer or possibly civil engineer or any engineering dealing with constructions or environmental generally, there are some times that you actually consider points, because in GIS we focus in three things, which I will explain that in terms as we continue. We focus is either we are dealing on points, or you are dealing online, or you are dealing on polygons. So there are some time that you actually need to locate some of those points. So as you can see, this is a flat tracking point showing location, the landing, the starting point and the landing of every particular flight from one country to another. Okay. So now, if you continue to the next slide, we have given you a brief explanation of what the GIS is all about. It's a computer system capable of assembling, storing, manipulating, analyzing, and displaying geographic reference information. What does this mean? GIS is a data visualization tool that is useful for looking at a spatial relationship and pattern between objects. Now, this is what I was trying to explain from the beginning of our webinar, where we are talking about relating building information. For example, your working drawing, relating it with your bill of quantity. Now, there is no direct relationship between those things because you use a different object or use a different software to do your building drawing, and then you are using a different software to do your bill of quantity. So there's no direct link. You understand? For example, except now presently we are talking about building information modeling. If you are using BIM, you can possibly look at that and then see there's going to be an interlink, because you can, let's assume your Revit now, you can be able to actually, if you are using a Navis work, okay, you can be able to generate a bill of quantity with it. You understand? So that is one of the aspect or the advantage of using a GIS software. Okay, there's a relationship between them. Now, GIS is not scary. It is not only for geographer. GIS is a tool which applies to nearly every field, including environmental engineering, science, humanity, and social science. The output of all the GIS, all those things you are talking, whether you are talking about location intelligence, location mapping, route designs, your site layout, the output of all the GIS data will be on map. Okay, and then you require what you need in GIS skills and literacies. Okay, so now this is, from my previous explanation, I mentioned GIS is being displayed layer by layer. You understand? So this is the typical explanation of what I mean by layer by layer. You overlay them one by one. For example, you have the satellite image, that is the whole world, and possibly you can overlay Kaduna state boundary to it, or you can overlay Nigeria as a country, the boundary of Nigeria on the world layer, and then possibly overlay Kaduna state on Nigeria, and possibly overlay a particular community or a particular site or your construction site now on that particular area. You understand? So you overlay them one by one. Now, this is this is what you can also possibly use as well to actually generate your contour or your topography map. Okay, so GIS are layered by layer. Then we talk about what can you do with GIS. Now, GIS show us everything. You understand? Show us where things are, like the location of everything. For example, you want to locate schools. Okay, you want to locate all the schools in Nigeria. You want to see all the hospitals in Nigeria, the locations. We are talking about the location. We are not talking about listing. We are not talking about writing the list on Excel. No, we are talking about location. That's why we talk about location intelligence. You can actually see the location of all the schools, see the location of all the estates that is registered in Nigeria, possibly all the hospitals. You understand? GIS can actually help you to see all those things. Now, it shows changes over time and track changes data. Now, if you are using a satellite image or you are using a Google map, it will definitely show you an update. Okay, it show you an update of your, for example, if possibly in last year, if you have a map showing that, okay, there is a particular building in these locations, but possibly this year now the building has been demolished. Okay, now if you view from the satellite image, as far as you view the recent data, it will definitely show you the real data of that particular environment at that particular time. Okay, and then another thing again is that see and communicate meaningful pattern in your data. What I mean by meaningful pattern now is like the roots, well, possibly when you are talking about when you are doing analysis now, the pattern at which a particular object is being arranged. For example, a pattern at which a school is being cited, or a pattern at which a communication marks is being cited. Because maybe if you work in communication industry, you discover that there's a pattern, there is a buffer they follow. You look at the coverage at which one communication mask can cover, then you can be able to know the exact or the next location where you place it. So these are all these are the use of GIS, and then the knowledge of GIS will help you to actually do all this. Okay, now this is a simple view of GIS data, okay, showing an area that has uncredentialed teachers. Okay, maybe a particular locations that, okay, the teachers are not registered. Okay, you possibly want to pick it that, or a particular locations where the buildings are not well organized, or a particular locations where there is no estate. You understand? For example, if you are working with a development industry, or you are working with an estate developers, or a company that are into estate development, you can actually use this GIS to actually locate, okay, from here there are no much estate here, there's no much building here, and then there are a lot of development going on here, but there's no estate, there's a housing problem here. You can use GIS to actually detect that and resolve or take your decisions with the GIS tools. Okay, now geographic reality. Geographic features are recreated on computer using data model. Now GIS is divided into two. Okay, that is the data of GIS is divided into two. We have the vector data and then we have the raster data. Okay, now the real world data is also there, but the main major GIS data are the raster and the vector. The raster is basically the image, possibly the satellite image, the old map that you have that you want to load to your map, or a particular pictures that you want to load, that you want to use as a base map to a particular things that you want to do, or an existing, let's assume if your building plan, your old building plan you have is coordinate related, and then you want to overlay it on an existing place that you want to transfer it to the real location where the building is supposed to be located. Those things are raster data. You understand? Then we have the vector. The vectors are those ones that you can edit them. For example, in AutoCAD now we have you can edit. If you draw a line, you can edit it. If you draw polygon, you can edit it. If you put point in a particular location, you can move it. Okay, so these are data. These are vector data because it's editable. You can be able to edit them. So in GIS we have vector and then we have raster data. Now the vector now divided into point, line, and polygon. Okay, so these are the three major data, or three major layers for vectors in GIS. Now we talk about the raster. Now raster break the earth into grid. If you view satellite image very well, discover that it's being divided into different grids. And that grid now help us in the resolutions, viewing how we can be able to view those resolutions. Values are assigned to each of the grids, and then values are assigned to each of the vector points. You understand? So all those things are one of the things we considered in GIS. So you need to put into considerations or put in your head that, okay, we have raster and then we have vector. Rasters are pictures, basically pictures or images, and then vectors are line, point, and polygon. Okay, so these are the common data features of GIS. Okay, now we talk about resolution. I talk about that on the raster side. It says that the raster is divided into grids, and then the grid help us in our resolutions. We have low resolution, large area, and then we have small resolution, small area. Okay, so as you look at this image, you see that some of the image, how clear is some are blurring. Okay, so this is how your raster data, or in viewing some of those resolution of data or images are in GIS. Okay, location of an object. From the beginning of this webinar, we talk about coordinate system, where we say that, okay, even AutoCAD or CAD software put into consideration the coordinate reference system. So now in GIS, one thing that you must put into consideration is the coordinates, because you cannot, we are focusing more on locations. Okay, we are focusing more on locations, so coordinate is one very important for us to put into considerations. And then how do we get those coordinates? You get those coordinates using a GPS device. Okay, we have, even in your phone, your phone comes with a GPS device that can pick a coordinate. You can use a Google map and pick a coordinate. You can use different applications that you can help to pick your coordinates. And then the coordinates also can be divided into or can be categorized into latitude and longitude. If you look at this shape you are seeing, these are longitude and latitude through the equators and the south and the hemisphere. Possibly in mathematics, we do that as a construction professionals, which we did not focus if we did not do this in geography. Okay, now we go to map projections. Now, if you look at the first image here, you say that the earth is spherical, right? Now, if you look at the second image, now the earth is flat. Now, that is when you talk about the map projection. The world, instead of that spherical shape of the world, now it's being divided into two to make it to be reprojected or to be projected so that it will look flat. Now, instead of the earth to be spherical, now you make the earth to be flat so that you can be able to take your grid. Now it's going to be vertical and horizontal grid to actually determine the coordinates. Okay, the image will be somewhat skewed. The different projection focus on different area on the earth and attempt to eliminate skew. Getting data to display in the same map projection is sometimes easier said than done. Okay, so now these particular projections now help us to have the earth flat, and then our coordinate become vertical and horizontal. That is to say, at the point where your vertical line and horizontal line meet, that is where you pick your coordinate. Okay. Now, in GIS, we talk about attribute information. That's when we talk about relationship between the object and then the information of that object. For example, you have a point, and then you have the attribute information of that point. Okay. Now, in building industry, that is one thing that we lack, because we, as I said, we do our drawing in AutoCAD or in any other software, and then you are preparing information, possibly the work schedule of it. Maybe you are using MS Project to produce a work schedule. It's a different software. There's no interlink between your drawing itself and then the schedule that you are producing, or the workflow that you are producing, or the bill of quantity that you are producing. But in GIS now, you can be able to interlink those things. You can be able to have your building, the particular building, the object, possibly the floor plan of your building. You can design it in GIS, like draw it in GIS, and then at the same time, you can link it with your schedule. Or possibly you are doing a road design, and then you have the shapefile or the polygon of your road covering your road, or the line that indicates your road. You can actually include every information about that road. For example, the length of the road, the gradient, or at what level, if there's a slope of at what level, or maybe there's going to be a cut and fill and all that. You can actually include all those information on your object, so that if you just click, it will display all the information that you need. So you don't need to go and check another software, or go and check a set to get information about a particular object that you have drawn. Okay, GIS project. Gathering data is one of the difficult things that we all know. Okay, it's one of the difficult things that in GIS. So getting data is actually not easy, but you can download data from different sites. Okay, it's now the two way or the ways that you can be able to get GIS data. One is you can just use your GPS and pick a coordinate, or you can possibly use the old map that you have, and then you digitize it, you scan it and bring it to your GIS, and then you digitize it. Digitizing means you draw it. That is, you draw line on top of the base map so that you have that shape, or you can download data from a particular site. Because a lot of sites, a lot of websites that provide, for example, I have grid3.com here. It's a website where you go there, you can download schools, maybe all the schools in Nigeria, all the churches, all the mosques, all the hospitals in Nigeria, you can download them. Okay, so these are sources or where you can get your GIS data from. Now, storing GIS data sometimes can be difficult because there are a lot of data that you'll be getting. So ability to manage your GIS data is another thing because it will consume a lot of space. Those images and some of those pictures are actually heavy because of their resolutions. Okay, so that is the basic, a brief explanation of what GIS is all about. Okay, and then we talk about the self-help. Let's assume you want to read more, want to know more about the basic of the GIS. There are a lot of resources and a huge users community online. Your question is not unique. You can just search for anything that you want to search for. Just type anything on Google about GIS, you read more about it. You can also go to QGIS documentation because, as I said, we are using QGIS for our practical, so it's going to be you can go to QGIS documentation. We have the web site here. Possibly at the end of this webinar, I'm going to send you this material as well, so that you can have access to all this information here, so you can read about it. You can also read ArcGIS documentation. Stock Exchange is also a site where you can download your data from. We have Jonet online community, Esri online communities. Okay, though these are places you can read more about GIS, and then you can get more GIS data from there. Okay, now how to learn more on, if you want to learn more on QGIS itself, you can follow us, CAD Structure can follow us on our YouTube at CAD Structure Technology. You can go to YouTube and search for CAD Structure Technology. You can read more, or you can see more videos related to GIS. Or you can follow us on our Facebook at CAD Structure Technology, or you can join our next online weekend full GIS training. That is by next upper week after this election week. That is this next week. We'll be starting our full GIS for weekends. Okay, it's going to be a 4-weekend full GIS training where we are going to show you everything as far as GIS in construction industry is concerned. How you can use it to digitize, how you can use it to do your survey, your site plan, how you can use it to do your logistics management, how you can do it, you can link your schedule with your building drawings and all that. All those can be explained in our next online weekend full GIS training. You can also contact us on our phone number, and then you can visit our on-site training center. Our training center is in Kaduna State, so our on-site training is in Kaduna State. So if you are around Kaduna, you can actually visit us, and we can have our on-site training there. Okay, so thank you very much for this opportunity to actually listen, for us to speak to you and this GIS for construction professionals. So I don't know if there's any question. Okay, now I'm not seeing any question on the chat box. I think before we go back to our, is there any question? If you have any question, you can unmute yourself and then you can ask your question before you go to our practical. Do you have any question?
Hello.
Yes, yes, I'm hearing you.
Yes, I have a question.
Okay, sir.
I I recall that you mentioned QGIS as a software that can be used for GIS operations.
Yes.
But at some point when you were mentioning either benefits of using the QGIS, you
Yes.
mentioned is it ArcMap, and then you were mentioning
Yes.
other things which I suppose are softwares too. So I
Yes.
wanted to find out what the difference is. What is the difference between that QGIS and ArcMap and then the other ones?
Okay. As I said earlier, in my presentation, I mentioned Esri. I'll talk about Esri and Autodesk. Esri is when I talk about GIS software, Esri is a company that designed most of the GIS softwares. But this QGIS is not designed by Esri. It's designed by a community of developers. It is free, but Esri is not free. Now, the ArcMap, we have Esri software, we have ArcMap, we have ArcGIS, we have ArcGIS Online, and then we have ArcGIS Pro. Yeah, now the ArcMap is the ArcGIS desktop. Okay, now those three ArcGIS features, or those three softwares, are all licensed software. And then for you to actually use them to the fullest, you need to pay for their license. But if you are using QGIS, which does the same thing with the anything that you can do with the ArcGIS software, you can also do it with the QGIS software. If you are using the QGIS software, you are not paying for any license. It's open source, and then it gives you room to actually develop your own plugin as well. For example, if you are a programmer, or you are good in developing things in terms of programming, you can as well develop your own plugin and add it. For example, if you are a quantity surveyors, and then you discover that there's no cost related, more possibly maybe the cost, maybe there's a particular plugin that deal with cost, and then that particular plugin now is not being displayed in naira, and then you can now, you as a developer now, you can also design your own plugin and then add naira to it, and as far as it's okay, and then you upload to the community of those developers, they'll approve it and add it to the software. There's a repository, there's a site where you download all those plugins from. So the difference between QGIS and ArcGIS is the fact that QGIS is free, is open source, is developed by a community, you don't have any restriction, you can collaborate with it, but ArcGIS is not free and you cannot collaborate with it except if you buy the license.
Okay.
Yeah. So I don't know if that answers your question.
Yes, I think I'm okay.
Okay, so there is no any other question. Please, I want us to take another 10-minute break so that we'll not have a breach after we start the next section. I want us to take another 10 minutes break. Immediately we come from that break now, we are going straight to the software. So if you install the software in your system, you can as well open it. But if you don't install it, there's no big deal. You can also listen to it. I can send you the video at the end of the webinar, and then you follow up anything that we're going to do. So this is here is 3:20. So we'll be resuming back by 3:30. So please join back by 3:30 so that we'll not have a huge an instant break again as we did the last time. So thank you very much.